comprehensive, and it should be self-managing and self-maintaining. And take away the islands. It shows like a living organism with information going to and fro, with nerve endings, and the nerve endings in this industry are biometric devices, mobile phones, barcode readers, RFID readers, hand readers, palm readers, fingerprint readers, and so on. Just information, whatever the easiest way of getting information from the field is, and the easiest, best way to send information and receive information. Here's another example of it's a shopping centre that we kitted out. It cost less than £1,000 to kit out this shopping centre. It's got extremely low frequency radio network. It's battery operated, so you don't need power points to plug anything in. It's just batteries. And the fobs are used by the cleaners, in this case, to interact with the system. The other thing about this is it's self-maintaining. If any device here goes down, we'll know about it. It's linked to a GPS, a GPRS GS phone, which sends the information to the server. This is, that transaction is handled by the software. So if it breaks down in the middle, it won't be committed to the database. It's exactly like, it's a fully transaction managed, except it's transaction managed remotely. If a battery goes down, the supervisor will get a message to say the battery is low. It'll start up a workflow. They'll be told what type of battery it is, exactly where to find the battery, where to put it. So the central nervous system controls many functions, and we would argue that to do this business properly, you need to have a fully comprehensive central nervous system. That doesn't mean that you buy one system that does everything. You can buy, as long as you buy one system that can interact with everything and ultimately controls everything. So my question, a rhetorical question, would be, how good would Google be if it only got 80%, if it only web crawled 80% of the servers on the internet? And would it be just 20% less good? I would argue that it would be almost useless, because everyone would use Yahoo, who does 100%. Now, similarly, if you're a CEO of a facility management company, you want to see how your performance is, or even the manager of an area, when you look at a screen, you want to see everything. You don't want to see just 80%. If you see the performance is going good in one city, good in London, good in Leeds, not so good in Birmingham, what can you tell about that information if you know you're missing 10 or 15% of the data? So you actually wouldn't use it, because you know you're missing possibly key information. You don't know what's missing. So you have to have everything. So you need a comprehensive system with all the data, just like Google. So it's like a Google for your work management. Just think of it like that. You need this kind of integration to get any use of it. It's not like you get 80%. If you can get 80% of the integration and 80% of the data, you actually need it all. You need a system to do that, to get the full benefit. So this is what a basic system would look like. It's server software which is comprehensive, configurable, collaborative, and connected to your complete operational area. Comprehensive, like I said, because if you only get a percentage of the data, it's useless. It's not actually only a little bit less good, it's useless. You can't use it. It has to be comprehensive to get all the benefits. So some examples of that, if you're getting some information from a barcode, someone in the field doing a barcode scan to say they've cleaned the room, for example, that can be used in quality audit reports. It can be used to display information to the customer to show you quality, performance. It can be used for timesheets. It could be used for work management, scheduling. You know when they were there, when they left. So after a while, you get to understand how long everything takes, not only in one little business, but in the whole business. You understand how to compare different businesses. So if you have businesses of a different size in different countries, with buildings of a similar size in different countries, you can compare. So after a while, you start challenging. So you build a lot of challenge into the whole business. You challenge all the time to get the best performance. It can be used for KPI generation, a host of things. Just one little piece of information from the field. But if you haven't got a comprehensive system at the back end, you can't use it. Comprehensive system doesn't have to have everything, but it has to integrate. It has to have all the information, whether it gets it itself or it integrates with other systems together. And there's another list of things which I'm not going to call out, which can make use, every single item there can make use of a barcode scan from a reader, a cleaner, or an engineer out in the field, asset tracking, whatever. There's not one thing there you could find that couldn't find a use for this data. So our approach to this was to build a fully comprehensive system which contains all this stuff: fleet management, alert management, scheduling, site management, health and safety, document management, online customer access, and so on. The system also needs to be configurable so that when you buy it, everyone has different contracts. Your customers come to you and say, I want this type of audit report, and my auditors are coming next week. This is what it has to look like. Or you've signed contracts with a customer and they want specific things, so you have to follow their flow. You can't just give them one system and say, no, you have to do it this way, or the highway. So systems have to be configurable. When these sorts of things happen, you don't want to have to write bespoke software. Even if you do sometimes find some strange requirement, there's no way out. It has to be bespoke software. You want that to be the absolute minimum if you want to have it maintainable and future-proof. So customers want to look at systems and information in different ways. So if you're a route-based company, you'll want maps and all this kind of stuff. If you're scheduling, daily scheduling is important. You want this kind of information that's down here at the bottom of the screen. See where the gaps are in the schedule. So if there's an emergency requirement, someone rings, you can look at the screen and see exactly where the gap is and find someone to do it with the right skill, right location, right availability to go and do the job straight away. So to achieve configurability, it's a technical issue, and you need to have something like MVC, Model View Controller. You can look that up on the web. If you go to In2Sequence.com, it's fully described. You don't have to remember MVC, but if you remember In2Sequence.com, you get all the information. It's a way that a product is designed to separate data, the data storage, from the data presentation. It's a technical issue, and it's either there or it's not there. If it's not in the product, it's just not configurable. Simple as that. There's other ways of doing it aside from MVC, but if it doesn't have something like that, it's not configurable. Simple as that. It has to be tailored for you. It has to be. You have to write bespoke software to achieve your requirements. Also, workflow engines. Everybody has different documents, different contracts, different requirements. So you might have from the simplest requirement of an inspection report to a complex contract. So everyone has different flows to manage the generation of documents and the completion of documents and the publishing of documents. So you need a workflow engine, in our opinion, to get any sort of reasonable connectivity. And all this needs to be underpinned by a rules engine, which is data where you can define rules. So when you get new upgrades of the software, you're not updating the rules. The rules are stored in data. When the software is upgraded, data is not updated. Also needs to be collaborative. So these are what we call conversations governed by software. So this means actions are pushed to people based on, derived action are pushed to people based on calculations done in the system. What we also have is escalation hierarchy. So if any job is not completed and based on the rules, when it should be completed, like time or various other events, it'll be escalated to someone above that who might be supervising it. So in normal circumstances, the supervisors should see nothing, but on occasions they will get an alert saying there's something overdue. So this makes it really easy for supervisors to manage work. They work in the knowledge that everything is being done properly. It has to be, because it's fail-safe. And they just concentrate on the exceptions, which is a good place for them to be. They know everything's being done because they're getting all that validation from the system, but they're also getting alerted to the exceptions, and to be able to visualize results. Okay, so the system needs to be connected, connecting people, devices, and also to existing systems. Connecting to devices means maintaining those devices in the field, so the system is managing itself. Okay, so just to repeat, my main message is I'm just telling you what the basic entry-level system is for facility management. The system needs to be comprehensive, configurable, connected, and collaborative. That's all I'm going to say right now. I'm happy to take some questions. Good question. Thank you. We're done.